Our team is not just a team that participates in the competition, but focuses on the learning process, the hands on experience, as well as innovation. Now, about the competition. Every year, ABU conducts a contest named Robocon, where the teams from Asia Pacific region represent their countries and compete for the title. In India, the competition is conducted by DD Robocon at IIT Delhi, and the team that wins the competition represents India at the main competition held at different venues each year. The competition has a game format where each game is between two teams, often named as red and blue. The playing field is symmetrical, and the robots from both teams start in the same condition. Now, about our team. Majorly, there are three departments in Robocon: the mechanical, which is responsible for prototyping, manufacturing, as well as testing of our bots. Majorly, there are the three electronics and embedded. The electronics department is responsible for powering the bot. They start from making all the battery packs, wiring, circuitry required to power our bot. The embedded system department can be considered as the brain of the bot. So they find out best algorithms, best code to control our bot and make it drive in any way possible. And finally, the research and development department. The research and development department is different from the all the three above mentioned because they think 4 to 5 years down the line and try to bring out the most cutting edge technologies to the table. Now, I would like to invite Monel Solani from the mechanical department to give us an overview about the same. Monel?
Thank you, Anish. So, the mechanical team focuses on designing and manufacturing of different systems that are to be placed on the bot. Complete manufacturing process is broken down in phases, namely research, designing, prototyping, testing, and the final assembly of the bot. We start with the research phase. Once we receive the theme for the year, we break it down in different tasks that are to be performed by the bot. Brainstorming sessions are held where we come up with the solutions to the problems presented as tasks. An initial design concept of the mechanism and the drivetrain suitable to complete the task are selected. All the different actuators and materials needed to fabricate the mechanisms are also selected. From the initial design concept, a 3D model of the same is made in designing softwares. The main software that we use are SolidWorks and Fusion 360. These are computer-aided drawing softwares used for 3D modeling of mechanisms and the drivetrain. Every mechanism are independently modeled and are later combined. The picture in the left is a 3D model of this year's bot with all the mechanisms and drivetrain made in SolidWorks. Another software that we use is ANSYS. This is a simulation platform used for FE analysis of mechanical components. Putting it in simple terms, FE analysis is the analysis of distribution of force on any 3D model. Here we have an analysis of a rectangular plate. The portion in the red is where the most forces are applied, and the portion in the blue is where the least forces applied. With the help of a 3D model, a mechanism 3D model of the mechanism and early version of each are fabricated. Multiple iterations are manufactured with improvements inspired by the faults in the previous versions. Any improvements in the design of the mechanism, if at all needed, are done during prototyping. Here we have an image of an early version of drivetrain which was used in the final bot. So for fabrication process, we obviously need tools. Our college provides access to sophisticated machining tools, 3D printers, and laser cutters. But we don't just rely on our college. We have used industrial grade water jet cutters for our fabrication process. So, as the name suggests, the prototypes fabricated are tested rigorously. During testing, we are on the lookout for any problems in the mechanism. If any problems are encountered, they are resolved and the mechanism is tested again. Here we have a short clip of our testing process. This is a prototype of our throwing mechanism and the catching mechanisms. The final part with the throwing and catching mechanism. This is our picking mechanism. Our placing mechanism. and finally our kicking mechanism. After testing of individual mechanisms, all the mechanisms and the drivetrain are integrated together to give us our final bot. But our work isn't done yet. The final bot is again tested with all the mechanisms on the arena. Here you can see both the final bots fabricated by our team for this year. So part of our future plan is to make more efficient designs for our mechanisms and drivetrain. We are also trying to implement series elastic actuators for some of our mechanisms. Collaborating with our electronics team, MCAD ECAD fusion is also being tested for better understanding of our designs. Now I'll hand over the slides to Raj Patel. He'll give you an overview of the electronics department.
Thank you, Molin. So, hey guys, I'll be giving you a brief idea about the electronics department. As Anish told that electronics department is powerhouse of the team. So our most important task is to supply the power to the robot. We designed the hardware part of the robot, which includes interfacing of microcontrollers with the sensors and the actuators. So, technically speaking, we act as a bridge between the codes and the mechanisms. To achieve that, we need printed circuit boards. First of all, we developed the prototypes on general purpose board, and after finalizing the circuit, fabrication is carried out. So these are the artwork layout of our PCBs that are designed using professional softwares like SolidWorks PCB, Altium, and Eagle. These are the final PCBs that are implemented on the robot. Sensors play a big role in the field of robotics. To achieve various tasks, our requirement of sensor varies. So we have to do a research on what sensors could be used to carry out those tasks. We use industrial grade sensors. These are the LiDAR and the laser sensors that we have implemented on the robot and are interfaced using AVR and ARM microcontrollers. Another thing is hardware debugging, which is the most essential one. This skill is much needed when the robot is malfunctioning or not working. Further, I will be talking about new implementations that were carried out this year in electronics department. So this year in our R&D, we developed a single as well as dual channel motor controller. Motor controllers are used to drive our DC motors more efficiently by changing the speed of motors. As you can see in the image, the left one is the dual channel motor controller and the right one is the single channel. Second thing that we have implemented is the PS controller. So we had designed a customized PS controller to control the robot. As you can see, the controller in the pictures, it consists of joysticks and buttons. It is capable to carry out 16 commands. The main objective of the controller was to simplify the communication with the robot over Bluetooth. For the first time in history, we carried out SMD soldering. So what are SMD? SMDs are the surface mount devices. You can see in the left image, these are the SMD components. Because of the small size, the overall PCB becomes compact. We carried out this soldering with a hot air soldering station. The whole motor controller, which I explained earlier, has SMD components on it. Talking about our future vision, we are looking forward to introduce OTA programming, that is over the air programming. So basically, we are planning to program the microcontroller over the air. Second thing that we are going to have is a ECAD MCAD fusion, which means designing the PCBs and the integrated circuits using 3D modeling. So in future, we are going to have a fusion of electronics and mechanical systems. Now I would like to hand over the presentation to Ansh. He will be briefing you about the coding department.
I guess there seems to be a connection issue with Ansh. So I'll be taking over from now. So about the embedded coding department, it can be considered as the brain of the bot, such as and it tries to interface between the sensors, which can be considered as your eyes, ears, and skin. So the coding department takes inputs from the sensors and processes it in embedded microcontrollers. All the programming is done in embedded C. That's a major role in TKR to program our bots and act as brain of the bot. Now, brainstorming sessions are also conducted before starting the final bot assembly. We try to take on the theme objective and try to find out the shortest or the most efficient part to uh, solve the problem. Members come up with ideas to be implemented on the bot in this phase. Now, testing of sensors and algorithms. We test the sensors on initial prototype of the bot and develop algorithms to control the robot. The left one is a lidar sensor, which basically gives us the distance between the bot and an object, for example, a wall or obstacle. The second one is a gyroscope, which is present in your phones and which gives us the angular orientation. So the bot will know its tilt and distance with respect to the base frame. And the final one is a rotary encoder, which gives us the rotation of the wheels. Basically, it will give a current output to certain number of rotations. Now, this is a video showing the wall following of the bot. So as you can see, our bot is following the wall straight and it's coming back when it's seeing an obstacle. Now, this is a bot spinning in circular ways to get a perfect orientation. This is done using the encoders and the gyroscope as mentioned earlier. Now, this is a bot traveling in sine wave motion, which is obtained using the sensor fusion of gyroscope and encoders as well. So as you can see, it's traveling in a perfect sine wave. Now, implementation on final bots. After the other departments have assembled and wired the bot, the coding team starts interfacing the mechanisms and sensors to a microcontroller. The current microcontrollers of choice are STM32F family, and also the manufacturer microcontrollers manufactured by ARM. These are the same microcontrollers which are present in your devices. For example, the Snapdragon 801 is based on the architecture. This offers amazing power compared to the previous AVR family of microcontrollers. Now, this is a demo video of us navigating the bot in the arena. The bot travels in a curved path to reach a certain destination. This is the second video where our bot is trying to reach a try spot to pick up a rugby ball. So the bot will stop here and pick the rugby ball. So these are the two paths the bot needs to travel in during the final competition. Now,
Sorry to stop you, Anish,
interfacing.
but
Yes, Deepak.
it would be better if you could go to the previous slide again because there was a lag, so people wouldn't have understood what happened there.
Yeah, actually, it's a
Okay, is it visible
lagging
now,
a
Dhruv?
bit, and yeah,
Is it visible now?
we can only see that PPT which is navigating the arena.
The video is not
Hello?
visible. Yeah.
No, we can't. Yeah, now it's visible. Nani.
Okay. So as you can see, the bot is traveling in a curved path to reach a certain spot to pick up the rugby ball right here. I hope that's visible. Okay. So moving on, interfacing the bot to the controller. The coding team is also
Anish,
responsible for making. Yeah.
Anish, I just have a small doubt. Hope you don't mind me asking one thing. Can you tell me one thing? Aren't we using Arduino in this
Um,
bots?
hey, can we keep the doubts till the end because we have a separate doubt session after this PPT.
Oh, I'm so sorry. I
Okay.
wasn't aware of that. Okay.
Okay. Cool. So interfacing the bot to the controller. The coding team is also responsible for making the controller made by the electronics team, as shown by Raj in the previous slides. So basically, the coding team programs the PS2 controller or the PS customized PS controller to give certain commands to the bot and control it in the most effective manner. Now, about the future goals. The team has been using the inverse kinematic model to gain accurate control over the bot. We plan to improve on this aspect as well. We plan to use better sensors and better code to improve the performance of the bot. Now that was an overview of our coding department. Now I would like to give you guys an overview of the R&D department. So I guess we can conclude that all the other three departments are necessary but not sufficient for this team. Let me explain how. The other three departments are bound by the yearly objective of the competition, but the R&D department isn't. We think 4 to 5 years down the line and try to bring the most cutting edge stuff, not only in coding, mech, but antronics also. So hence, I can conclude that we are working on the junction of all these three departments. I hope there is no lag in the slides. Okay, moving on to our roots. We were established in 2018 as the MATLAB and IP department. So basically for the simulations.
It's hanging now.
Okay,
Anish, it's hanging actually. I can't see them.
I'll stop the sharing. I'll share it again. Just a sec. I hope you can see the R roots for the slide.
It's showing that and it's sharing. Yeah, now I can see it.
Okay. So I hope you guys saw the overview slide. Okay.
Yeah.
So speaking about our roots, we were established in 2018 as the MATLAB and IP department. So basically for simulations. So the top left image is a simulated arena and the bot has to travel according to the path planned before. So this is entirely done in MATLAB. The top right image is a snapshot of our algorithm or the neural network detecting the rugby ball in motion. So that's a big deal. And the last image is our proposed throwing mechanism simulated in MATLAB for testing our hypothesis. Now, computer vision, it's a big word, right? So what is it? Speaking in layman terms, I hope you can see there is a rugby ball in here. As humans, you can perceive that there is a rugby ball in this image. But for a computer, it's just an array of values. So it cannot perceive whether there is a rugby ball. So to bringing the computer from perceiving an array to knowing that it's a rugby ball, image processing is that gap. It bridges the gap between these two. So in general, we can um, conclude that image processing bridges the gap between perception of the computer and human. So I hope that was clear. This was achieved using training cloud VMs and neural networks on approximately 2,500 images. So that was quite a tedious task, but these are the results and they are pretty amazing. Now, MATLAB. So I guess I told you guys you're using MATLAB, but why do we use it? It allows us to create and simulate a virtual environment. Well, what's good in that? Basically, instead of creating and prototyping each mechanism and fabricating them, we can just simulate it in MATLAB and get accurate results. So it saves us both time, effort, as well as manpower. That's a major advantage of using MATLAB or any simulation environment for that matter. So I guess you can see the snapshot of our throwing mechanism. I'll play it for you guys. I know it doesn't seem like much, but trust me guys, it helped us in the final stage of our prototyping also. Now this is a video of a drive path simulation as I showed you guys earlier in the coding department overview. Basically, the bot travels in two diagonal paths and one curved path. This was achieved on MATLAB itself, and it looks quite impressive rather than the previous throwing version. And another major reason of doing MATLAB is there is a competition at IIT Delhi in stage 2 of Robocon. So these are the perks of using MATLAB. Now, enough of the past, let's talk about the here and now. So we are trying to implement the two-track theory. The first one is staying connected to our roots, which is simulations plus computer vision. So we are trying to make more advanced simulations in MATLAB as well as implement object detection and tracking on board. What I showed you guys in the previous slide was done on our laptops or our machines, which were quite heavy lifting machines. But to do it on a bot is a completely different story. We need to get into dedicated GPUs like the Jetson TX2 or the Jetson Nano, as the computer vision stuff, it's quite heavy duty. Now, the second thing is ROS, Gazebo, and SLAM. This is an entirely new beast. So you might ask, what is SLAM? So SLAM is basically simultaneous localization and mapping. What is it? So basically, your bot will know its position in its entire environment completely automatically using the sensors like lidar, encoders, RGB cameras, etc. So the first step towards the SLAM is mapping. So you have to map the environment first using lidar scan. The second one is embedded integration. We will integrate the SLAM software to our embedded coding bot team on our bot. So this couldn't be done right now due to the COVID scenario, as we don't have access to our hardware. But this doesn't stop us. We're doing advanced simulations on Gazebo to achieve our goal. I know that was a lot of information in the past 30 seconds, but I hope this sums it up. This is a short video of everything I talked about. Oops. Yeah. So I hope you can see the video. The top left is simulated world I created in Gazebo. The top right is the output of the Kinect sensor, which is attached to the car. So basically, it gives us a 3D model of what the car is seeing. The bottom right is the output of the lidar scan. I hope you can see there is a blue arc around the car, which is the region of influence of the lidar. So it will detect any object which comes in under this area. And the bottom left is finally the RGB camera. As you can see, that's the output of it. Now, about the future vision. All that I talked about earlier was done in 2D. So basically 2D SLAM, 2D object detection. But we are planning to do all this in 3D. So you might ask, why do we have to do it in 3D? Because if we do 2D SLAM, we can only get the position of the obstacle, not the shape or size of it. So it will be difficult to avoid it if we don't have the exact size of it. That's why we're trying to implement the 3D SLAM, which will give us a 3D depth model. As you can see in this image, it's showing a point cloud of the image, so which is a 3D model. And we're trying to achieve it using stereo vision. So basically, stereo vision works just like human eyes. There is a separation between the two cameras, which gives us depth information and helps us create a 3D model. Our second goal is 3D object detection. 2D object detection was just fine, but 3D object detection takes it to another level because it has sensor fusion. It uses the lidar sensor to get the shapes of the object present in the environment. As you can see, it can detect the shape of the car, giving us uh, more accurate results than what we would be able to achieve using 2D object detection. And the final dream of our team is 3D SLAM and complete bot automation. We're doing this to make our bots more faster and efficient, and it would help us to complete the task a whole lot faster and also eradicate the possibility of human error. So this is the dream of our entire team. Now, I would like to walk you through some of our achievements. Team KJC Robocon 2020 earned its valor by scoring 100 on 100 in stage 1 of Robocon 2020. Unfortunately, we couldn't do anything in stage 2 as it was cancelled due to the COVID scenario. In 2019, we also secured AIR 5 at stage 2 at IIT Delhi in 2019. Here are some of our other achievements. We scored the most realistic project in Yantra. Also, our design was given as the most efficient design in VLSI design and conference. Now, I would like to thank our faculty advisors, Dr. Irfan Siddhavantam, HOD of IT, and Mr. Vijay Bhosle for mentoring us throughout these years and guiding us through our difficulties and problems. Now, I would like to call upon Rajat to tell us more about the recruitment process.
Yes, guys.
So the recruitment process goes like this. We'll float Google Forms to you all after this orientation in this week. Uh, those who are interested will register their name in the form, and the further information will be conveyed to you. Then the next thing I would like to discuss with you is why to join TKR. Okay, as you have seen and as you have learned that each department has its own importance. Okay, everyone will get exposure to the growing field of robotics. You will get to know all the software required to operate and make the robot. For example, SolidWorks, AutoCAD, ANSYS, Eagle, Atmel Studio for AVR, and MATLAB. There will be hands-on experience to you all. It's for sure. To all those who are interested in robotics as well as in joining the team. This software is used in industries as well as in your engineering course. So it means you are going to know lots of new technical terms. It will improve your skill set and make your profile stand out from others. And also it will give you a critical thinking which helps you in problem solving. We are giving you opportunity to show us your skills and dedication. You will also learn a lot. At the same time, you have to manage the situations which will help you to cope the problems and improve your skill set. That's it from my side. Do fill the Google Forms we have floated in the chat box, and now feel free to shoot your questions by unmuting yourself or putting it in chat box.
Can I ask one question?
Yeah.
Yeah, yes. What my question was that we are not using this Arduino for the robots.
So can you hear me?
Yeah, yeah.
Yeah. So we don't use Arduino in the actual robot, but when we are researching the sensors, we use Arduino to interface them. But as we move ahead, we can't use Arduino because it limits our capability of the processor of the microcontroller.
Oh, acha. Okay.
Yeah.
And by the way, where the forms will be there on the chat box itself or in the mails it will be posted.
The recruitment form will be posted on the mail, but I would request you to fill this form as well, so that we can keep track.
So we can should we go on the mail and fill the form?
It will be floated in the next week.
The form on the mails will be floated on next week.
Yes.
The forms
The
you mean
recruitment
will be
forms will be, yeah, the recruitment forms will be floated next week, and then you have to register yourself, and we'll be taking details, and further notice will be provided.
so the form will right now you aren't posting anything on the mail, right? Apart from right now, apart from the form, right?
Right now, you just fill the form that is available in the chat. The recruitment forms will be sent to you in the next week, so you can fill that
Okay.
in via mail.
Okay.
Any other question regarding TKR or any technical problems do you have?
So whether it's sufficient to have MX 250 NVIDIA graphic card for these softwares. Hello.
Yeah,
For
yeah.
what software, like for the MATLAB IP
For,
and research development?
for all softwares which are necessary in the 4 years, whether MX 250 NVIDIA graphic card is matlab, minimum
Yeah,
or
yeah. It will be more than enough for our current needs, and we'll get
what?
GPUs from our college as well. Like college will provide us with resources also if we need anything more than that. So your GPU
Okay,
is
so
just
what?
fine.
No, so what's the minimum GPU you need?
See, your MX 150 is just good enough. See, anything which has CUDA cores, your GPU has CUDA cores, right? Around 350 or 360. That would be enough. And it has 2 GB VRAM. So that would be enough, I guess.
Yeah, it's
It will
2
work.
GB.
Yeah,
Yeah, it's
I
2
know.
GB. MX 350.
Yeah,
250. So,
it will be enough. Any other doubts, guys?
Please feel free to ask the questions. We are open for it.
Yeah, hello.
whether for
I have
coding,
a question.
whether for
Yeah,
coding you use Mac or Windows.
We use
it's
both the
not.
platforms.
Yeah. See, I'm currently using Mac for R&D, but my team members are using Windows, so it's not a limitation. You don't need to have one platform or the other. Okay.
Hey, I joined a bit late. Can you explain the
Yeah.
coding aspect of the whole robotics team, please?
Yeah. Ansh, if you will.
Just in short.
Yeah, so basically we program microcontrollers to control the mechanisms on the robot, and we also you navigate the robot across the arena autonomously. So we basically write algorithms for that into the robot.
Okay, thank you.
Hello.
Hi,
Yes.
Kritika.
You talked about ROS and gazebo. So, have you been implementing that topics into your robot, or are you going to, or something like that?
See, we don't have the access to robot right now, so we'll be implementing it once the college reopens.
No,
That's
have
why
you
we're trying.
implemented before? That's the question.
No, it was this year's goal, as in we are achieving it
Okay.
this year.
Hey,
Hi.
hey, hello,
Yeah.
hello.
Yeah, you're audible. Speak up. Okay. Any other
Yes, Uchit.
doubts?
Um,
Hello.
yes.
Yeah, Uchit, speak up.
Yeah. So, is there machine learning and AI involved in this whole team, or and is C programming or means Python programming also involved, or it's just
Uh,
C?
yes, Uchit. The object detection part was done using machine learning and neural networks, and we also used Python to do OpenCV and learn the basics of image processing as well. And C
So the
programming will be used in the coding department, or rather, I'll be more specific. Embedded C will be used there.
so CS people have a scope in this also, na? That's what I am saying because in majority of the mega projects, the CS and IT people don't have a big chance to get in. So that's what I was asking basically.
Yeah,
That's a
Yes.
misconception. That's a major misconception. I'm from EXTC and I'm doing coding. I'm in the R&D department right now, so department is not a question. Okay.
Hello,
and
am I audible? Actually, I'm also from CS department here, and actually, it's quite useful for me as well. Now, I've learned a lot since 1 year because I was here in this in this team since first year.
So
And
you all will
embedded,
teach us from basics means if we don't have any experience from before. So is it
Yeah, yeah.
okay or we need to have some prerequisite experience
The
or
only
something like?
prerequisite you'll need is having good logic. That's all we need. So we just need to know you're capable of learning what we teach you.
So you
And
alongside,
all don't require us to learn any language or something from before, right?
no, no.
and just
Okay,
wanted to,
thank.
I have a experience on this Arduino board, Java, C++, and currently learning in C in Somaya. Are these things enough? Or do you think if I know these much things, I can be a part of Robocon? Will these things?
See, you don't have to know any language. Okay, it's a added
Okay,
advantage if you know all these things. We'll train you guys from the start. Okay, so you don't have to
okay.
know C or Java or anything else. Just your logic
And
should be clear.
and the embedded systems is basically the electronics, right? Because the mid-range designing the processors, controllers, that is basically embedded systems, right?
It's not entirely electronics. It's a um, junction of both
Mixture.
electronics and coding. Yeah, you'll be working on
Okay.
the junction of that. So you have to create bot and wire it sometimes, or you have to code it in software completely. It depends. It's not entirely electronics. Electronics department is different, and embedded is a
So
bit different.
like in the embedded team right now, there are people from the electronics department who are coding, as well as there are people from the CS IT departments who are coding the embedded systems as well. So there's no limitation to departments in any of the teams, any of the departments.
And if anyone is not having doubt, can they leave the meeting?
Hello.
Yeah,
Hello.
once you fill the form,
Yeah.
just a second, you
Yeah, I
can
filled
leave
the
the meeting
form.
once. Okay,
I
Yeah.
filled
sure.
the
Hello.
form. Is it
Yeah,
I
Shubham.
can leave it, right?
Yeah.
Yeah, yeah.
Actually, I'm not able to access the link. Means I'm not able to see the chat section. How can I fill the form?
Dhruv, can you check whether the chat is working?
Wait a second, I will check that.
Hello.
Yeah, Pratyush.
Yeah.
Wait a minute, Anish. So is the chat enabled now? Are you able to see
Yeah.
that?
The chat is enabled, but I can't see the link there.
Wait a second, I will refloat it.
Yeah.
Hello. Hello. I wanted like approx how many students will be recruited in the R&D section and the coding section.
It actually depends on how much demand there is. I guess we don't have an exact number right now, but it depends how many of you guys are interested. Also, we have to split the others in other departments as well, as in electronics mech also. So it depends on the demand, as in how many of you guys sign up for the aptitude test and also the interviews. So all
All
these
right.
details will be shared with you on the mail. You don't have to worry about that right now.
Okay. Thank you.
So if you
You would be
joined
having interviews.
in the
Yeah, Nirav.
so in the Google form that you've uploaded, in that you've asked us for our preference of
Yeah,
department.
yeah.
So if uh, if our preference of department isn't there, we can join other departments also, right?
As in there are
Yes,
We'll
only.
we.
talk after that
This
later.
is
It's a part we'll decide it later.
Okay.
We'll see what are you interested in. Okay.
so. It's just we're
Afterwards,
collecting
we'll
data
decide.
right now as to what y'all are interested in right for now.
Hello.
Okay. Okay. Thank you.
Hello.
Yes, yeah. I guess someone was
Will
saying.
you be guys having interviews for recruiting?
Yeah, all the recruitment process will be shared with you on the mail. So don't worry about that. So are there any other doubts?
There's a doubt in the chat box.
Hello.
Yeah, Harsh.
Yeah, my doubt was, is there a marketing team for TKR as well?
Currently, we are only handling the management and marketing part. There is no dedicated marketing team for that.
But if you're interested, you can join. Okay. If you're interested, there's a
Okay, so if we are interested in, while filling out the form or while filling out the recruitment form, what interest should we show in that? So can we select anything, any of them?
you can select R&D. You can say like R&D.
Okay, yeah. Thank you.
Hi, I have a question. Hello.
Yeah, Samudra. Yeah, Samudra.
Yeah, so in the end, if I fill in the form and give my selection of department, will I be given the department of my choice, or will you be putting me in the department of your choice?
Will the interview will be deciding factor for that. So we'll take an interview and we'll judge whether you're more stronger in electronics or coding or R&D. So we'll just take your preference for that, and finally the interview will be the decider. Okay.
Okay, all right. Thank you.
Yeah, Miraj, can you just?
Yeah. So the for the doubt in the chat box from Jyoti. So we conduct brainstorming sessions. Each department basically conducts brainstorming sessions. So the mechanical team will make the chassis according to the theme, and the electronics team will decide which sensors we need to use, and the coding team will come up with the algorithms according to the theme every year. So that's how we start with the bot making process.
So, guys, if you have any doubt, just speak up, unmute yourself, and you can just ask us.
If you don't have any doubts, you are free to leave, but just please fill the Google form uploaded here.
So you can choose any preference. The na- make so you can choose any preference. You can select all of them for now if you aren't sure. Mariam, the tentative dates will be basically we'll be floating the forms this week. So the coming week will be the, the week we're talking about. So after you all fill up that form, we'll analyze the aptitude,
Tentatively,
your
the
aptitude.
registration process will be completed by October first week, so that's not a major issue.
So, if there are no further doubts, then we can end this session. If you guys have any doubts, please post it in the chat or unmute yourselves, or this will be ending the session in the next 3 minutes.
Yeah, hello.
Yeah, Nirav.
So, like, I'm not entirely well versed in robotics, but I want to learn, but I'm really interested in the field and I want to learn more about it. Are there any websites that you would recommend or something like that?
Uh, okay, sure. Just contact me on the WhatsApp number provided in the Google form. I'll share some resources with you. Is it fine?
I actually submitted the Google form. I can't view it again. So, can you put it in the chat?
Okay, sure. I guess it was floated in the WhatsApp message also in your official groups.
Okay, fine. I'll check over there.
Yeah. Thank
So
you.
you please put that on that group only. You please put that on that group only, so we can also the different materials.
A group will be
Hello?
created after the, yeah, you're audible, Shubham. The group will be created after the recruitment mail. Okay.
No, no, the group that you have made now, FYITG or other groups, on that official groups you put that what we have to refer for
Actually,
that
we
analysis.
can't, we don't have the authority to do that. It's not, it's for basically Stuco. We are Robocon, that's different. That group is created by Stuco. It isn't a group of Robocon. So we can't just post resources in there. Okay.
We'll be floating a Google form, and then we'll be taking your details, your contact details, then we'll be forming a group of all the people who have registered. So so in that group, we'll be sharing all the details, whatever you want. So just a little patience, and next week we'll be sharing the Google form. So don't take any intention of that sort.
So I guess if there are no queries, we can just end this session. Dhruv?
So are we sure that we are ending the session now? So if you still have any queries, you can contact the numbers provided in the mail to get your doubts cleared. So thank you for attending the session. It was great to have you here. I will be ending the session now.